Hi everyone. Okay, welcome back to the section 3 of the module 1 for your AI 900 Microsoft Microsoft AI training. Um, the last session we look at the hands-on lab where I took you through anomaly detector. If you remember, if you have seen that. Okay, so yeah. Remember, we started from the cognitive services, and one of the cognitive services we look at is the anomaly detector. So now, another harms of your AI, don't forget, is 4. Okay, so the second one that we're looking at into now is your machine learning. Okay, so this concept sound a bit funny though. Machine learning now, you know, I mean, it's sort of quite a funny concept. But to be sincere, we really let you know. We just wanted to know what it means when we say machine learning. So machine learning is the foundation for most AI solutions. Okay, and it enables the creation of models and predict unknown value and infer insights from observed data. So what you need to know about machine learning is that um, it is a way of making a particular system to learn something by themselves. For example, using a method called models. So with these models, you train this model and you iterate it. Iterate means you repeat the process. Okay, so you create a model, you feed this model with some certain amount of data, and then you repeat the process. Okay, so at the end of the day, this machine can then predict some unknown values and then refer or make an inferences or provide an insight into the observed data. So so how how do machine learn? Okay, the answer is from data. From data. So machine learn from data. So what does that mean? What kind of data are you talking about? Do you mean the data I use for browsing? No. Well, one way or the other, that's a form of a data too. But you see, your data can be representation of your binaries, zeros and one. Your data can be in figures. Your data can be in images. Your data can be in text. Your data can be in different forms. You can have structured data, unstructured data, semi-structured data. Okay, so in different forms. Your data can be in JSON script, JSON format, it can be in Avro format, different form of data, of course. So, but we have had developed machined environment or software environment where you feed this information to these machines and they create a model, repeat the process, and bring out an insight for you. So the answer is yes, machine can learn and they learn from data. So in today's world, we create huge volumes of data. So have you ever thought of the amount of data that goes on the internet? Let's think of it. Have you ever thought of the amount of data that goes on Twitter? Millions of people tweeting at the same time. That is data being generated via text. Have you ever thought of the amount of data that goes into Instagram? That is data, 95% of data generated via images. People just post pictures. Remember, less words, more pictures, because pictures speak volumes more on Instagram. Okay. So have you ever thought of your Facebook? Your Facebook is 50% pictures, 50% text. Like people gives enough information about the image you've posted. So imagine millions there are over 2 billion active users, of course, of Facebook. So imagine 2 billion people putting information out there. So they need a system that need to analyze this information. So the process of analyzing, creating models and doing all of that, that's where the process of your machine learning comes into play. So your machine learning, aid analysis, aid insight generation, helps us in, making decisions very fast or, so that, for example, when you have volumes of data you cannot work with, the machine has the ability to work with this and then do a whole lot of stuff. So for example, so when we create a huge volumes of data as we go about our daily lives, for example, from text messages, emails, social media posts. So we send to the photographs. So we send to the photographs and videos we take on our phone. We generate massive amounts of information. More data still is created by millions of sensors in our homes. Okay, so these are another parts of it. So of course, the other parts of the world where we are, we might not have so much of sensors, but for the developed countries, they're having smart homes, smart home devices. Okay, with smart home devices, computer laptops are talking to the curtain are talking to the fridge is talking to TV. You understand? Most of these smart devices are voice activated kind of devices like Amazon Alexa. You understand that? So all of these generate enough data to be to be to be analyzed. Okay. All right. So so as a data scientist, you cannot be far away from learning more about AI. So AI and data science are integrated, sort of. So data scientists can use all the data to train a machine model. So the key word here is model. So a data scientist create a model, that can make predictions and make inferences based on the relationship they found on the data. So suppose an environmental conservation organization wants volunteers to identify and catalog different species of wildflower using a phone app. Now look at this information now. So let's say you work with an NGO. Oh, this NGO says, oh, we want to name all species of a particular wildflower. Okay. So and you join them. So what do you think will happen here? Okay. So that means you'll be part of the team of the botanists and some data scientists. So what they will do, they collect some sample of these white flowers, as in that particular flower, and the team will label the samples with, with the correct species, right? Okay, then the label data now, that is that particular flower that has been labeled, is processed using an algorithm that finds relationship between the features of the samples and the labeled species. So let me explain that. Okay, because it's a flower, so they will have different kind of features. Okay, so once you label a particular species, you can say, oh, this particular species has this kind of handtail, this one has this kind of pollen, has this kind. So you look at the relationship. So when you see another type of species that looks similar to it, it's easier for the machine now when you feed that information to the machine, it's to that software, it's easier for it to locate, for it to pinpoint and say, oh, that's that kind of flower, that same species. Okay. Then the result of the algorithm are encapsulated in a model. So as you can see now, you create an algorithm like a code, like a programming that's been coded in a way that will identify the species. So it is packaged as a model. So this model is rerun again and again, repeated again and again to identify different types of species and flower. So when new samples are found by, let's say, by you as a volunteer, what do? The model can identify the correct species based on the label that you have provided. You understand? So now, what are the type of machine learning? Okay, so there are two general approaches to machine learning. You have the supervised machine learning. You have the unsupervised machine learning. So both have a goal of capturing a model or equation. Remember, model is reoccurring. This model has created by data scientists. Okay, and so either in supervised machine learning or unsupervised machine learning, the goal of capturing a model, both have a goal of capturing a model that will try to predict a result. So the idea is this: whether you are using a supervised machine learning model or a not supervised model, so this model is to also predict a result or label it that is as close as the actual result as possible. Okay. So both approaches require an input of data. So we call different group of data features. Remember your features. For example, if you have a particular flower, there will be features. So these features, you can group them together and then input them. Okay. All right. So now for your supervised learning, you know, So when you say supervise, what do you mean? So this relies on us, you and I, as a, or maybe a volunteer or a team of data scientists or whatever, having some sort of data with a known label value. So remember, we've gone to do that NGO work. We've collected different wildflower species and all of those things. We have labeled them. You understand? Now we've known the features. Now we've created, our data scientists have created a model. So now, so supervised learning means that this relies on us having some data with known label values that we can fit to a model. So we've created a model from the first, from the other slide that I showed you. We've created a model, so which can then be applied to a new data. So because there's a pre-existing data, so when you see a new species of wildflower, it's easier for you to pick the information from the new species and run it against what we have initially. Okay, so which can then be applied to a new data for which we don't have the label value, of course, because it's a new data. So label are what we to predict, okay, such as house price, an item in an image, or if someone has diabetes. So that's label. So for example, if somebody has diabetes, so you want to run the new information you are getting from these diabetic patients against a model the hospital has created, or the data scientists in that hospital has created for diabetic patients over time, right? So it's easier to run the label or that information you are getting, that data you are getting from a new patient against what you have. Do you understand? So both approaches require an input of data. So like you said, we call different group of data features. So now look at type of supervised machine learning. So we have regression and then we have classification. So we are still under supervised learning. So for supervised learning, so when you want to carry out your regression, what do you use? Use predict a continuous numeric value, like a price, a sales total, or some other measure. So for classifications, used to predict a continuous numeric value. Okay, so for example, like a price. So let's say price for fuel. Okay, so you can do a regression analysis on it. Why? Because the price of fuel it kept changing per time. Okay, do you understand? Foodstuff price in Nigeria, of course, kept changing. So you can do a regression analysis on that. So you can predict. You can say, okay, with the rate at which it is going by so time, the fuel might be sold for 250 naira, something like that. Okay, so classification used to determine the probability between zeros and one data belonging to a particular group. Of course, it's just to classify your data. All right, so for your unsupervised learning, remember we have both supervised and unsupervised. So for your unsupervised learning, so this is an approach that trains a model to separate items only based on their features. Okay, but remember in your supervised learning, you have to bring a new data from an existing features and use it against a pre-existing feature, a model, right? So here, this is an approach that trains a model to separate items only based on their features. So there is no previous known cluster value or label. So there's no known value. So this one is just creating, you just train a model, you just begin to separate them into different features from which to train the model. So one type of unsupervised machine learning task is clustering. So one of the things you see under unsupervised machine learning is clustering. So what's clustering? So this is used to determine a label based on how similar the item is to the items in the label group. So clustering means just basically grouping similar items together. Okay. So model training and validation. So the learning component of machine learning, occurs during training. So we try to capture the relationship between the features and the label in a model. So training is the action of iteration. Training is the action of iterating on an algorithm for best fit or encapsulate those relationships. Like I said, the learning component of machine learning occurs during training. So you need to create a model and then you train this model. So training this model means that you are repeating the process. That is what we mean by iteration. Okay, you iterate. Okay, so we try to capture the relationship between these features. Remember the features that you have gotten and all the labels that you have. So all of these are put together in a model, and then you keep to train. So training is the action of, so to, when you say you are training, you are repeating that process of creating the features and labeling all over again and again and again to give you a model. Okay, so the information you put together in form of programming or in form of a code is what we call algorithm, or the process that they will go through. Of course, you know what an algorithm means. If this happens, say yes. If this does not, say no. You know, that kind of a thing, or repeat again and all of that. So after training, we have a model that we can now test. So we can use some of the data set aside, validation data, to test how closely our model predicted label are to the actual label. So when you want to train, you also do what we call validation. So what you do is you use part of this data, you set them aside, and then after finishing the training process, what you do, you now kind of put them side by side to see how closely the data you have trained within the model, the prediction that comes out of that model. So you can now see, okay, are they closely related? Are they very close? Or there's a wide gap? Of course, so for model training and validation, there are many types of evaluation metrics. The important things to remember is that the goal of machine learning is to find a model that gets as close as possible to predicting the actual label. So look at this. So the goal of any machine learning is to create a model. So this model must get as close as possible to predicting the actual label. And remember what your label is. Your labels are the informations you have gathered. So when you create a model, that model must be able to create the actual events that caused them to be gathered before. So the best model can still have some margin of error. Okay, so training and validation processes. So what you do, you can split the data into a training set and a validation set. Okay, and then apply an algorithm to fit the training data to a model. The trained model encapsulates the relationship in the data. Use the model to generate predictions from the validation data. Use evaluation metrics to compare predicted versus actual label, which is your supervised, and measure cluster separation, which is your unsupervised. Then repeat the process. Okay, so repeat this process. So that helps you in training your model. So we have automated machine learning. So training and validation process. So an automated machine learning helps data scientists to increase their efficiencies by automating many of these time-consuming tasks associated with training models. Okay, and it enables them to use cloud-based compute resources that scales effectively to run multiple training experiments in parallel while incurring costs only when actually used. So what this is saying is that in order to, all the process we've spoken about can be automated. So which means you can use cloud-based compute resources where you can scale. Maybe you want to use 2-3 machine, a machine before. So when you have more models to run, you can increase it to 3, and then it runs efficiently all at the same time. You know, and all of these are automated and stops as at the time due, and then does not cost you much. Okay. So in Azure machine learning, multiple steps workflow to prepare data, train models, perform model management tasks across pipelines. Okay, so in your machine learning, you do multiple step workflow to prepare data. So when you prepare your data, you train your model, and you perform model management tasks. So these are called pipelines. So you can create the pipelines where you prepare your data, you train your models, and then you do a model management. So the designer tool in Azure Machine Learning Studio enables you to create and run pipeline by using a drag and drop visual interface to connect modules that define the steps and data flow for the pipeline. Okay, so your designer, this is you can see this in your learning studio. So when we go to the next lab, you will see all of this. It might look so tedious right now, but just be sure that we have proper understanding by the time we go into the lab. So where you can see work on Azure Machine Learning Studio. So because within the studio, there's what we call can create pipelines using drag and drop. So there's a designer tool there where you create pipelines within the studio. Okay, so within the designer here, you can create, so these are the workflow. Okay, so for example, you have diabetic data, then you've normalized your data. So normalizing your data means that you've broken those data down in from bigger chunks or smaller chunks that can be used. Then you can create what we call your two-class logistic regression. You can split your data, create a training model, score your model, evaluate your model. You know, this is like an algorithm for you. Okay. So here we are going to be doing a lab, an hands-on lab, as that is speaking to your Azure Machine Learning Studio, so where all those things I spoke about, where we'll be able to practicalize them. Okay, so with that, we have come to the end of this class, and see you in the next class when we jump into that lab exercise where we are able to do that. Thank you so much for your time.